Here's the solution to the second problem from section 6.2. It's very similar to the first one. We're given a normal distribution of 10-year-old boys' heights centered at 53.5 inches, and we're given the standard deviation, so you should feel free to label the 3 tick marks in either direction that we know will be part of most observations. So the question is, the first question is, what proportion of these 10-year-old boys are tall enough to ride the roller coaster? And it says that the rule is that the kids have to be 56 inches tall. So obviously that or taller is okay for riding the roller coaster. So 56 inches is going to be in here somewhere if you label it. And so this is the area that we want to try to find, is the proportion of the curve that corresponds to 56 inches or more. So what we do is we move this over to the z-score distribution, which we know is centered at 0 and has 1, 2, 3 in each direction. And the line's going to be about there, and it's going to be shaded like that. So the question is, where is this line? And so that line is the z-score for 56 inches. And if you calculate the z-score of these of 56 inches in this distribution, it turns out to be exactly 0.50. So we can look up in the table, or table A is the table we keep using for these distributions, but the table always shows us the area that's shaded to the left of a particular curve that we look up. So if we look up a z-value of 0.50 in the table, you'll find that it says the area is 0.6915. If you're not sure how to look up a value in the table, I'll do that at the end of this video. So the area of 0.6915 actually doesn't apply to the shaded area I drew. It applies to this stuff on the left-hand side of the arrow. So 0.6915 is the area to the left of the line at z equals 0.5. The table always gives us the areas to the left. But if I only want the area to the right, I just have to subtract that from 1. So the probability that you have a z-score that's bigger than 0.5, which is what I want, is just 1 minus the probability that I have a z-score of less than 0.5. And that latter number is this table value of 0.6915. So when I subtract that from 1, I end up with 0.3085, which is the value that you see already filled in. The B part is going to be very similar. The new roller coaster, the smaller roller coaster, you only have to be 50 inches tall to ride, and so that's going to be to the left of the center. So this is 50 inches. Remember, it's the same picture here, so this is 53.5 is still the middle, so 50 inches is over here. So I'm just trying to save a step. Translate that to the z-score distribution. These are my z's. It's going to look like this, and I just need to know what z-score this is. That'll be the z-score that I would get from 50 inches. Still subtracting 53.5, which is the mean, still dividing by 5, which is standard deviation. And that z-score will be exactly negative 0.70. So just like before, the probability that z is at least negative 0.7 is 1 minus the probability that z is less than negative 0.7. I'm doing exactly the same thing again. Looking up negative 0.7 for z in the table gives me an area of 0.2420. So when I subtract that from 1, I get 0.7580, which is the number here. So what we're finding is that we need to find the area larger than a certain z-score. Then all I'd have to do is look up the table value, which is the probability of having an observation less than the z-score, and subtract that from 1. So this gives us a strategy that always works. Why does it do that? Weird. This gives us a strategy that always works. We need to find area shaded to the right. We can just subtract from 1 the area shaded to the left. Okay, the last question is actually pretty straightforward now that we have these two pictures. I got to think about how I'm going to combine these two pictures here. If you want to know the proportion of the boys that can ride the second roller coaster but not the first one, that would be the stuff that's shaded here. Any boy whose height falls into this range but not this range will be in the answer to C. And so that's just this much area minus this much area. Just literally think about all the boys that are counted in this area and subtract the boys that are counted in this area, and that'll be your answer. So it's just going to be the difference of these two values. So if you subtract this minus this, you're going to get 0.4495. So now I'm going to go on to the next slide to just show how we look up the values that we got here, the table values, these two guys, probability that z less than 0.5 and the probability that z is less than negative 0.7, come from table A, and so I'll do that on the next slide. So here I can illustrate how we find the probability that z is less than 0.5. That was an important part of our problem. To do that from the table, I just have to find the z-score of 0.5. So I go down here to 0.5, and I want 0.50. So this is the first part of the z-score, and this is the last digit. So 0.50, I get 0.6915. That was the value that we got on the previous slide. So that's the area of the curve to the left of 0.50 as the z-score. So the trick we did on the previous slide was to say that this part, the shaded part above 0.50, is just 1 minus 0.6915. So if you can find the amount below the line, then you automatically know the amount above the line by just subtracting from 1. So now let's see how it would look different if we had a negative z-score. For the other part of the problem, we had a negative z-score. So we needed to find the probability that z was less than negative 0.7. So think of this as negative 0.7 as a z-score, and the table is going to show us how much area we have over here, the shaded part. So again, I'm using my rows and columns of the of the table. So I go down to looking for negative 0.70. So here is negative 0.7, and this is 0.70. So negative 0.7 is the first part, and then ends with a 0. So 0.2420 is the proportion of the curve that's shaded to the left of negative 0.7. And of course, in the problem, I really needed to know the probability that z was greater than negative 0.0, which is this area, the white area. And so we know since the total area under the curve is 1, then the unshaded area here is just 1 minus 0.420. So that's how we got the two values for the probabilities in this problem.